Today we're going to go over the algebraic representations of the transformations. We're going to start with the algebraic translation, then we're going to do the algebraic reflection, and then we're going to do the rotations about the origin. These are rules that you're going to follow to make these algebraic translations, reflections, and rotations. When making a translation, you're sliding right or left, up or down. The x-axis is horizontal, the y-axis is vertical. So if you're going to slide right, you will add to your x value and your y value will stay the same. If you're going to go to the left, you will subtract from your x value and your y value will stay the same. If you're going to translate up or down, you're going along the y-axis. So your x value will remain the same. You will add to your y value if you're going up, and you will subtract from your y value if you're going down. When doing an algebraic reflection over the x-axis, you will multiply your y value by -1. So please remember that this x negative y does not mean it is a negative, because if the value was negative and you multiply by a -1, it becomes positive. So in terms of these problems, the negative sign actually means you're going to the opposite. So when we go over the y-axis, you will multiply each value, x value, by the -1. So this means opposite x, same y, when you go over the y-axis. When doing an algebraic representation for rotations about the origin, we have a 90 degrees clockwise. So when you're looking at a clock, to the right is clockwise. So when we talk about a 90 degrees clockwise, you will multiply your x value by -1, which means takes your x value to its opposite, and switch your x and y values. So you're just switching your x and y position. A 90 degree clockwise is the same thing as a 270 degrees counterclockwise. So when you're doing a 90 degrees counterclockwise, well, counterclockwise would be going to the left. You will multiply each y value by -1 and then switch your x and y positions. So again, this becomes an opposite y x. Again, a 90 counterclockwise is the same as a 270 clockwise. When you're making a 180 degree rotation, you simply multiply both your x and y by -1. So they stay in xy order, but you go to the opposite x and opposite y. Again, it does not mean negative. It means opposite x and opposite y. A rectangle has vertices at 0, -2, 0, 3, 3, -2, and 3, 3. What are the coordinates of the vertices of the image after the translation? So our original xy, we are subtracting 6 from x and subtracting 3 from y. So when they ask us to describe the translation, we need to say, what does that mean? That means we are going to go 6 to the left and 3 down. So we're going to take each of our original coordinates and subtract 6 from our x value and subtract 3 from our y value to get a new set of coordinates for our image. So I've shown the work for my x and y for each of the 4 points to get my new coordinates at -6, -5, -6, 0, -3, -5, -3, 0. Triangle ABC has vertices A, -2, 6, B, 0, 5, and C, 3, -1. Find the vertices of triangle A', B', C' after a reflection over the x-axis. So what you want to do now is go back to the top and look what a reflection over x would do. And so when I go back to the top and I look at the information, I remember that reflecting across x will give me the same x value, but the opposite y value. So try them. So A prime is same x, opposite 6, negative 6. B prime, 0. 0 never has a sign, positive or negative. Opposite 5, negative 5. C prime, same x3, opposite of negative 1 is positive 1. So A prime, B prime, C prime. So let's look at number 3. A triangle has vertices at J, negative 2, negative 4, K, 1, 5, L, 2, 2. What are the coordinates of the vertices of the image after the triangle has been rotated 90 degrees counterclockwise? So go back up to the top, find 90 degrees counterclockwise, and review the rule. And the rule says opposite Y, switch. Opposite Y, switch. Try it. So following the rule, J prime would be 4, negative 2, K prime would be negative 5, 1, and L prime would be 2, negative 2. Triangle LMN has L at 1, negative 1, and M at 2, 3. Triangle L prime, M prime, N prime has L prime at negative 1, negative 1, M prime at 3, negative 2, and N prime is at negative 3, 0. What are the coordinates of vertex N, and describe the transformation? So look at what you have. You have M and M prime, 2, 3. So from new to original is what we're going to do to find N. So we're going to look at it and say, okay, what did we do? Well, we did opposite X, switch. Well, opposite X, switch means we did a 90 degrees clockwise move. So if our new N prime is at negative 3, 0, remember that 0 has no sign, so N would have been at 0, negative 3, because 90 degrees clockwise is to multiply X by negative 1. Well, 0 times negative 1 would still be 0, and switch. And since negative 3 has to stay the same. Please add that 0 has no sign to your notes. Remember, 0 has no sign. It is not positive, it is not negative.